Okay, so we are live. So today's session is going to be very hands-on. Okay, I want to show you the applications we have. And let's see here, screen. Here we go. So I will start off with a little bit of the PDM. There are a few things I want to show you that are important. They are important selling points of the solution. Okay, I'll try to finish this part quickly so we can focus on today on MDC and DNC Max. So just going back here to our presentation, okay? So yesterday we covered uh, Simco Edit with the machine simulation. Simco Edit, we barely touched it because there are so many advanced functionalities, but I just tried to show you the PDM running on the top of NC Base. It's very important to understand that when you have when you want the PDM module, you also need to order the Simco Edit option. There's no way to get only the PDM client because the PDM client is actually a plugin, an add-on that runs inside the Simco Edit. So that's why they are integrated. You have PDM, DNC, editor, machine simulation, everything in one single interface. You don't have to open multiple different applications. Everything is on the same toolbar, and the reason is because the PDM is actually a plugin from the editor. If I want to show this very quickly, we are not going to deep dive technically, but if I go here to the editor, you're going to see that when you have the proper license, if we go here on the editor plugins, we have this option here, NC Base and DNC Max client. Okay, so that's why we are able to um, run a PDM client or a DNC client inside Simco Edit, and so we extend the functionality of the editor. Okay, I wanted to make this clear. And today we're going to cover DNC Max and the scheduler as well, MDC, the machine monitoring. So instead of uh, presenting PowerPoint slides, I'll deep dive on the applications so you guys can have an idea of how this ecosystem works together. Very important to highlight that all modules are designed by the same vendor. So what is our advantage over other monitoring solutions in the market or other DNC solutions in the market? One of the biggest challenges that the industry faces is that they consumed the previous generations of the solution, so previous generations of, machine monitoring or ERPs and schedulers or DNC software, and they're all separate. They are all built by different companies. So the companies, the business, they struggle to keep these applications running year after year because each application comes from a different vendor and they have to integrate these applications, make them work together, uh, and debug them, and troubleshoot the problems. And when they call, one vendor, the vendor says, "Oh, it's not my problem. You have to talk to the other guy, or you have to build the interfaces between these two modules. We do not, talk to other applications." So this ecosystem here is designed by the same vendor, by Simco, to work together. So what's the advantage for us is because the customers will get SolidCAM from us and a set of tools, this software suite that will be integrated tightly to SolidCAM, but between themselves, these modules already work very nicely together because they designed it to work together. So they have one vendor, one company that takes care of all applications or critical applications for their business. And this is what's going to be our differential as well. On top of the pricing point, affordability, we also own the whole ecosystem and they will get all the support, training, everything from us. And we will be able to solve their issues, regardless the module that they need help with. So this will also be a strength that when they consider or work with previous technologies that are all, manufactured by different companies, they don't have that advantage. And to sustain these systems, it's a burden. Okay. So today we are focusing on DNC Max, MDC, and Scheduler. So let me close this application here, this presentation. I'm not going to use presentation anymore. So let me just resume here very quickly things I want to show you in the PDM client. So this is, like I said, is not a generic PDM solution like SolidWorks PDM or Autodesk Volt. This is dedicated for manufacturing and to manage NC programs. So the first thing is that customers can have up to 20 custom fields that can be configured in the PDM. So in this example, I configured these fields to be drawing revision, programmer name, forging, drawing, product family, but I could have another 10 fields. I can set if they are uppercase or not, if they are read-only, if they are numeric fields, they do not accept letters, maximum length. So this way, you have PDM fields that can be integrated to other solutions like ERPs, flexible manufacturing systems, but you are enforcing some rules like I do not accept letters on this field, should be a numeric value like a barcode. Okay, so you can do all that here as well. One of the things that I showed you yesterday very briefly is the logging and the status text, so you can create life cycles for your programs. So this one is a little bit more sophisticated than yesterday's. You can set a program as proven or under development when the programmer is working on it. So if I go here, for example, and say this program is status, so look at this field here, locked, right? Locked means that the transmission cannot occur. You cannot download or upload this program to the machine. So if I go here and say change status and I say this program is under development, the system will automatically lock the field and prevent transmission. So if it's under development, which is what I'm trying to convey here, I can enable a column here and say show me the status of this program. I can say it's under development. So that means I'm applying a drawing revision or waiting for another tool. I could go here, say add nodes and say program is locked because we are waiting for the new EMUG tap for super alloys. And now everybody can see that there's a note here. Nobody can pretend they didn't see it. You see, even when I change views, the note is always there. So you're communicating without using paper why this program is locked, why it's not available to be transferred to the machine. Because I'm waiting for a tap. So you're preventing someone to run a process that needs a better tool. So right now I'm going to change the stats and say, well, it's ready to run. The tap arrived. Okay, so when I do that, the system removes the locked flag. So now I can transfer this and I can clear the nodes and do this. But one thing that I want to show you here before we move to DNC Max and MDC is one of the major pains in a major pain point in a machine shop is when they have sub-programs. This is very common in small and mid-sized companies that started without a CAN system, or a company that has families of parts. Not always they use a CAN system, but they have sub-programs. So what is an important selling point of our ecosystem? First, because we are offering SimCoEdit with machine simulation and all that, they can simulate parametric programs, macro B programs, programs featuring conditional logic, things that a CAN system does not really generate or generate well. So you can simulate any type of code here using G-code. The second thing is if they have these legacy programs, you can also offer them the possibility to handle sub-programs. So especially if they have families of parts. So look what I'm going to do now. I'm going to select two programs here. And one of the things you can do is you can mark a program as a sub-program or not. So right now I'm going to just leave this as no. I want to show you the process. So what I'm going to do here, I'm going to say these programs, they are subprograms. This means that we can manage in the database the parent and child relationship between these programs. I'm going to do one more so I can show you. And one of the things I can do is say, let's say that this is my main program and these are subprograms. It's difficult for the operator quite often to figure out which are the subprograms. He needs to read the program, he needs to download or copy them to the USB stick one by one, browse the network folder if they don't have a DNC. So how we manage this on a SQL database, on a database that manage relationship between files. So I can go here and say this program here is main subprograms. I'm going to select the main program, link it to this program. So I'm going to say, search the database for me for this machine. And I want to make this program the main program for my subprogram. So now you can see here that I have a small relationship here. I can activate some columns and say, show me, for example, if this is a subprogram, show me the relationships between these programs. So let me just move these columns. And you can see now that this is a main program, so it's not a subprogram, but there is one subprogram linked to this. And if I look at the subprogram, yes, it's a subprogram, and there is one main subprogram linked to this. So let's continue with this and say, now I'm going to make another subprogram to be a child of a subprogram too. So I'm creating a nesting relationship here just to test, the limits of the solution. So I'm going to go here and say, this program here is also a parent of my R003. And for my R004, I have also main programs, and I'm going to make 003 as a parent. So now you can see here that every event that we created, you see the event history shows, tracks the relationships between these programs. And I can go here, click on the 001 and say, send this to the machine. And now the software queued two files instead of just sending the main. So you can see here that this is, the main of the two subprograms. So I could change the relationship here and say, show me the relationships again. And I can, establish more relationships or say, hey, this program here is not a subprogram. So I cannot set that relationship. So you see, if I go to the DNC now, you can see that the system sent, these two programs. If I click on the 003 and send, it's going to send three files because they have relationships between them. So let's see what are these relationships. 003, 2, and 4. So if I open now the simulator, I can see that the DNC took care of all the relationships for me. So this is really amazing, guys. It's a big selling point for customers that manage subprograms because we solve this old problem in the industry where operators need to figure out which are the subprograms, or I may have, for example, a main program that is in the correct drawing revision, but the subprograms are not. How do I protect the process or the operator against making mistakes? So I could go here and say, this program is locked, this subprogram. And if I try to send this now, the system is going to say, hey, there's a dependency here that is locked. So the main one is okay, but you cannot send one of the subprograms because it's not matching the latest drawing revision. So the system is protecting us and managing all these, relationships between the files. This is amazing because not only protects you against mistakes, but also helps you to find very quickly what you need. So you can see here that we have now all these programs, sent to the folder because the DNC did that for us. I could even, go here and show you this is like a simulation environment, but I could go here and say, well, Mandeli and monitoring and send. So I'm going to delete everything. We're going to go back here to the CNC simulator, nothing in the folder, and I'm going to click here. I'm going to say send this to the machine. Of course, I can't because I have that dependency blocking me. So I'm going to say it's okay now, ready to run, and I can do that again. 3 files sent, queued for transmission. If I go here, my files are there. So the DNC system is creating all this, there's this interaction between the DNC module and the PDM module, and it's taking care of this. Okay, so I wanted to show you this. It's a very important feature. This is the only PDM manufacturing-driven PDM solution in the market that can manage subprograms like that. There's no other product in the market that can do this. It's a very cool selling point. You can manage subprograms. You can, uh, generate reports about your subprograms. Let's say, for example, that you need to change a tool, like Sandvik basically said, "Hey, I have a better insert or a better grade for you." And you should replace this insert in all tools and all programs that are calling this tool or using this insert. You can pull a report here, check all sub programs and main programs that are using a given tool, and then you can make mass change, and replace the insert, because the database tracks all the dependencies that exist between these files. So you can also manage customers. So let's say, for example, that your customer is a job shop, and he also serves other customers. So he could say, Acme Manufacturing, MFG, is a customer. I can go here, give a reason. I can also manage a project and say, hey, this project here is a big mold, China. Okay, and then say, Chevrolet, tracker, dashboard mold, whatever. It's a project. So you're going to manufacture multiple parts for this project. Okay. So what you can do here is you can click on a program and say, hey, this is linked to Acme Manufacturing and Big Mall China. You can also put other values here. Say this program is meant for serial production. The programmer is Alice. You can put like a drawing revision here if you want. Forging drawing is DWG F1234. You can do all these things. And what happens is that now, let's say that you need to find all programs in the database that you have created for the Acme Manufacturing customer. Or let's say that you want to find all programs that you create for the big mold, for that Chinese company. Or you want to check all the programs that are proven in the system. None of them, but ready to run. So you have, all this PDM functionality where you can find programs by part number, drawing. You can search the inside of the file. So let's say I want to find all files that contains the word T01M6. I need to replace that by something. The software will search the whole database for us and say, oh, this program contains T01M6 and is ready to run. But if I clear this flag, then it's going to search the whole database and say all these programs here contain the word, T1. So if I open that and search for T1, I'm going to find it right away. Okay, so very cool, dedicated functionalities for manufacturing and operators. Okay, you can go here, like I said before, and manage it, your documents here, your process documents, so you can store, capture the know-how without having to write too much text. See your tool lists, update them parametrically, so the system is reading, parsing the CNC program and extracting the tools that are called inside this program. You can also do that. Okay, so let's go here on Simco Editor, edit, and then go to the next tool change. T28, what's the next tool change? T15, only 2 of them. And the system parsed the program and extracted this and built a report for you. based on that information. Okay, so I wanted to finish with the PDM showing this. There are really a lot here, but I showed you probably 5–10% of the capabilities. But these are, the things that uh, everyone should keep in mind, that we have a PDM system that manages sub-programs exceptionally well, customer projects, advanced search capabilities. You can do mass changes in programs, replace tools in multiple programs at once. Very powerful tool that is connected to a DNS system that is physically, linked to the machine. It's not something like hey, copy the file from your PDM to a USB stick and put it on the machine. No, we can put this program directly on the CNC memory with the right click like this and say send. Okay, so finishing this, I'm gonna minimize it, probably close this one. We're not gonna need it anymore. And now I'm gonna kind of, give you a general overview of DNC Max. DNC Max is a extremely powerful tool. So I'm not gonna be able to kind of, show everything it can do on a webinar, but I want you to know the main advantages. We can support any type of functionality, covering machines from 50, 60 years ago with the serial parts and tape readers to the latest Ethernet, TCP/IP, and advanced protocols. So Simco is always on the cutting edge of connectivity because they need to be. They have a very large user base using their technology, and Simco invested heavily in the last 10 years to move from technology that depends too much on hardware and make monitoring and all these things that I'm showing you to be based on software, which it means Ethernet capabilities. And why I'm explaining this, I think it's something you need to use also as a leverage against our competitors. The first generation of DNC of monitoring systems started around 20 years ago, approximately, and the first generation created the technology from the scratch. But back then, you have to depend, heavily on hardware and pull electrical signals from the PLC, ask technicians to show up at your factory and change your PLC so the guys from monitoring could, capture signals. And back then, there were early adopters, but it's a little bit bittersweet because many companies abandoned that generation of monitoring as the technology evolved. Collecting signals using analog hardware became like a burden, hard to sustain. The machines are evolving, they don't need that anymore. Implementations were very expensive because you need to pay someone to change the PLC, someone to buy a lot of hardware to do that. I'm not saying that we don't need that at all. For very old machines, sometimes it's the only way, but there's always a way. Regardless the type of machine, there's always a way to monitor. But the ideal way is when you go towards software-based monitoring, which means plugging an Ethernet cable on the CNC or the PLC and getting everything you want through TCP/IP, through Ethernet. But the first generation, although it was the first attempt to trailblaze the path, 5–10 years later it became a burden. But the companies like Simco started to move away from software, from hardware-based solutions, and started to invest a lot in developing protocols, because a lot of these protocols did not exist or were controlled by a very small number of companies in the industry. And companies like Simco started to develop their own protocols and connect to this new machine. So today they have so many protocols that can cover literally probably 95% or more of the CNC controls that exist in the market. And when they don't have a protocol because the machine is too old, we can always go back to the old ways and install an equipment like this on the CNC to pull an analog signal from the PLC. We call this MOX IO logic. There are many models. It depends on the number of outputs you want to export, get from the machine. You can get up to 64. Most people start with 16, But you put an equipment like that on the machine, you collect the electrical signals from the PLC, connect them to one of these ports, and then you can read the signals through an Ethernet port, and then Simco can also work with very, very old machines, 30, 20, 40 years old. You can monitor one way or another, but it's not the best way. The best way is if you can, do this through Ethernet. So with DNC Max, you can literally, this example here shows a machine that with an Ethernet connection. So we call this protocol network monitor. I want to show you that, if you want to cover, let's suppose you need to cover, machines that are very old. So you have all these, templates in Simco DNC. You can literally connect to almost anything you find in the market. Heidenhain, Okuma custom protocols, things that are, heavily guarded by the manufacturers, or things that are like developed 25, 30 years ago. You can do this. This is a good example, for example, Deco Dialog 4. This is 30 years old, 35, probably 40 years old technology. You can connect to these things. But if you have like a Fagor control, you can also do that without, workarounds. You're going to use Fagor protocol. You have Fanuc bubble cassette, very old stuff, or punch readers. So you are always covered with Simco. You have, from FTP to serial protocols, Heidenhain custom protocols, Mazak Cyber Monitor protocol, very exclusive from Mazak as well. So you can do literally everything you want, and you can cover, very advanced things, like to the point that you can go here, and let's say you have a flexible manufacturing system, a cell that runs, lights out, and you want your MES system to feed, or your flexible manufacturing software to feed programs to the machine using DNC Max. So you could say, okay, I'm going to use like, this protocol for Fanuc, or for Siemens, or for Heidenhain. So I'm going to say Fanuc, you're going to put the IP of your CNC, and it goes to the point that you can say, for the Fanuc focus protocol, I want to even select the program in the control. So let's say localhost, and I can say rename this. You can use, fields to control what you want, but essentially you can have even the ability to say select the program on the DNC Max, send to the machine and select the program automatically on the CNC control after you send it. This way you can run a lights out cell, okay, with DNC Max. You can say, receive this file, and then once you do that, execute an application that's gonna kind of, update a TV or send an email to someone. So very advanced. I don't want to really go deep dive here on send and receive functionalities, because every DNC is supposed to do that, and Simco will do that, but you can do a lot more than most DNCs can do there. So if you need to have a solution, a technology that can work on very complex projects, customers that are implementing flexible manufacturing systems or high-end machines, palletized machines, this technology here solves literally all your challenges that exist in this kind of implementation. So what I'm trying to say is that SolidCAM is surround itself with proven technology that's up to date with the latest trends in the manufacturing technology industry, but also something that, it's there's a journey here to learn all this, but it's not really uh, quite difficult to learn DNC. It's just too many options, but you can really work on advanced scenarios that most DNC solutions can't. And we have all these protocols here right now off the box: Fanuc Focus, MT Connect. You can connect to Mazaks, to Okumas, Huruku controls. All of them use MT Connect. Heidenhain, you can connect directly to the CNC, and then say, hey, this is the control type. Look how many types of Heidenhain models this system covers. And then you can say, every time that someone press cycle start, send this message to the monitor system or cycle stop. But it goes to, some advanced stuff like, I'm going to show you FANUC, which is a popular control. You can also say, hey, every time someone push cycle start, send this message, cycle start to the monitor system. You can monitor the spindle overrides of the machine, rapid feed roll hold. You can say, if the spindle speed is between 0 and 30%, then, send this the spindle speed rate 1. And then if it's 3179, send the message, speed rate 2. So you can tell exactly what you expect. And this allows us to monitor things like this. Okay, we can monitor rapid override, we can monitor feed override, we can monitor spindle override, but not only that, we can also go here, for example, and say, spindle load. I want to check if the spindle load is between 0 and 30% in terms of, using the power. I want to go here and say, load, rapid feed. Where are you? So feed hold. We need to create a message here for spindle load. It's probably not on this, demo setup, but you can create a message. I'm going to show you that later. And then say, if the spindle load is between 0 and 1% or 0 and 30%, send like spindle load equal 1, and then 2 and 3 and 4. So you monitor everything. But let's say you have an advanced thing that you cannot capture using the default option. So we read the PLC, and that's the advantage over analog signals, because when you have analog signals, you have to make a choice. You have to say, I'm going to get 4 or 8 outputs from the CNC, and that's it. You cannot add more. But if you are reading the PLC, and this is why Ethernet-based solutions are better. Let's say that I open the electrical diagram, okay, of the machine, and I want, for example, to say I want to monitor if there's an emergency on the chip conveyor, or if the spindle is on low or high. Okay, so you can, coolant gun. Sorry, I want to know if the operator is using the coolant gun, or blowing, or the W-axis is clamped. So let's say I want to know if the Y-axis of the machine is clamped, is locked. Okay, so this is the PLC address. It's a Y5 bit number 7. Or if I want to check if the air is blowing on the spindle, is Y5 bit 5. So how we capture this? I want to show you that this is not really rocket science. I can go here and say, well, the name of this is going to be air blow, the signal that I want to capture for this machine. It's a bit, so it's a Boolean, can be 0 or 1. And then format text, if you want to format this, you can say, hey, it's a bit is represented by 1-digit 1. So I only go here and say percentage 1. You can click here on the help, and it's going to tell you how to use that field. And now I go here and say, it's a Y address. Remember, on the PLC, on the electrical diagram, it says the address is Y5. So it's a Y type address. And I say PMC address is 5. And the bit is also what? 7 or 5. So if I want to check if the air is blowing, is Y5 bit number 5. So I go here and say Y5 bit number 5. And then I can say, if this value is equal to 1, then I know that air is blowing, right? Because the PLC bit will be 1. Then I can send a message to the monitoring system and say, air blowing, or I could say alarm on. And if the bit is 0, I can say alarm off. So that's how you measure these things. You capture these signals from the PLC. You can also, store telemetry data. So what's telemetry data? I want to have a history of all changes in speeds and feeds on the machine. Every second, I want to capture the stats of the feed override, of the spindle power, and I want to put that on a database. Or I want to capture all the alarms of the machine and put on a database. I implemented this in Saudi a couple of years ago, and the maintenance, manager came to me and say, operators collide the machine on third shift or second shift and they hide it. But so next day we have problems, but we never know exactly who did it or what the time. When we go to the machine, sometimes the alarm is gone or it's been a number of hours that the logbook was overwritten. And they say, can we do something about this? And we implement the telemetry for alarms. So we monitor the PLC alarms. Every time there was an alarm on the machine, uh, MDC was or DNC Max were capturing this alarm and storing on the database. And then we could look at the database tables and see all the history of alarms of machine for the whole year. Every time an alarm occurred, we could see the database very easy. You can put this on Power BI, send per Excel, whatever. And then these guys basically could tell exactly at what time the turret collided or an alarm about the sensor started, and they could tell who was working on the machine at that time. So that was an example of doing advanced, capturing using telemetry. Telemetry is, as the name says, it's something you want to monitor at every, X seconds and put that on a database. Another example I implemented in the same place, in the same location, welding. Welding is a very difficult process because it's a special process. So you need to control the parameters so you have the outcome, the result you expect. It's not like machining that you move the dial on the machine, you know, a tenth of an inch, and then you cut a tenth of an inch on the material. Uh, Welding is not that accurate, but you need to control gas pressure, temperature, welding speed. All these things are important because if they are not okay, then your result, your weld will not be good, right? So they wanted also to track that. Hey, I want to know if I have a gas interruption during the process or the operator reduces the speed of the welding, and what happened, the depositing the material, you need to control the speed. So they implemented this, and then they could say, hey, every time there is a reduction here on the welding speed, we have a welding failure. And I can show you exactly when it happened and at the time, because I have, telemetry enabled for that machine. So these are examples of scenarios that we can solve with this technology. I would say that sky is the limit. Maybe is a lot. We need to be careful with that. But I could not find, in the last 10 years, 15 years that I work with this technology, I could not find a situation that I could not solve. So I think that most of our customers will be really happy, to have these capabilities. So this is the DNC, and I wanted to explain this to you because the DNC is the module that collects the information from the machine, the utilization through these protocols that I showed you. So if you have, cinematic control, you need, for example, to use the OPC client. If you have a Mitsubishi control, which is very common on the Swiss type machines, from Star or other partners we have, they use lots of Mitsubishi controls. So we could also have, support for that. Or Modbus for anything that is like, let's say you have an oven, a furnace, a robot, a conveyor on the machine, uh, an automated device that is not a CNC machine. You could also have a little PLC there, and you could capture the information through Modbus protocol, and for example, if your brake press is working or not, or if your furnace is working or not, and which temperature is inside the furnace, because you can do this. Okay. Finally, it's so advanced to the point that you can also write on database. Okay. So let's say that you have something here, like, I'm going to say a variable, demo, and you can create a condition for that, and you can write, a formula that says when something happens, send or write, on the database of this uh, server or something. Let's say, SAP server, a ERP server. So I could go here and say, hey, I want to write on the SQL database of this server every time there is a ME30 or end of program on the CNC machine. You can do that. You can connect to Oracle, Microsoft, or MySQL, and you can write, a query here, with the information you want to write, like, capture the cycle time from the CNC and writes on the database, of the server or your ERP system or your flexible manufacturing system. So I don't know if you guys can realize the power we have here. What I'm saying is that an event that occurs on the CNC control can drive, another event, can trigger another event like writing on the database of a ERP system. All this through your DNC software. I want you guys to understand the power of this, because we would be positioned in a way that we can solve very complex problems. Most of the times we solve easy problems, but we can also solve complex problems. Okay, I want to give you a general overview here with some pictures. This is not SolidCAM for Operate. This is the PDM client running on the shop, and then customer had Vericut and was storing Vericut files on the PDM. They are Vericut. They also have something like SolidCAM for Operate. It's a viewer. They have a viewer version of their files. We installed this on the computer. Operators could see and simulate the preview before the process before they run it. Gives them a lot of confidence, reduce the cycle times, because they don't have to be so careful with the feed over height and going in single block mode. So this is the machine. Here's Simco managing the simulation files. Could be machine simulation like I showed yesterday. An operator can see this without printing any paper and without having the programmer in front of the machine. This is an example of capturing signals from a Siemens control with a numeric control for a vertical lathe. You plug, a connector there, or you can also plug, Ethernet cable directly in case you guys wanted to see it. So this is the machine, a vertical turning center with Siemens control. We also implemented this for big WFL mill turn, also Siemens control, monstrous machine. We're very successful with that. Okay, let me see what else. Yeah, another view of the CNC machine. So this is another look into the adapter, getting data from the machine PLC, clean installation, just plug and play, and then remotely you can, pull the data you want. If you have the electrical diagram from the machine, very easy. Don't need to know electronics in depth, because the electrical diagrams are very clear. They say this is the signal of the pump, like I showed you. So you don't need really to be have skills in electronics. I don't have it, and I never had any issue to implement this. Okay, so this is like a funnel control. Again, Ethernet capabilities. We set an IP on the control, and then we can read whatever we want from the CNC. These are the PLC, parameters. And then again, another example of an electrical diagram. Spindle tool, unclamp, air blow, tool broken. W-axis is a horizontal boring machine, so we can really do wonders here. Okay. So here, for example, is a two-axis lathe with a turret. If you want to know when the turret is moving or when the turret is clamped, or when the spindle change the gear, we can do anything, guys. Does it make sense to monitor the turret rotating? No, but I'm trying to tell you that we can do it. You guys don't need to know electronics to, for example, to go here and say, hey, if the turret is rotating, then on this machine is also Y05 bit number 7. And we're going to train you guys extensively to work with this technology, okay? These are the PLC bits. So if I wanted to monitor, for example, the M06 command, if the automatic tool change cycle is running, I would go to the address R0715 bit number 7. So how would we do this here? Would be R means a relay. So I would go here and say, focus, funnel focus. I want to monitor this variable. And I'm not going to, fulfill all the fields, but I want you to know that, the address is R0715 R0715 bit number 7. And that's all it takes. Now you are monitoring that signal from the PLC, and you can do whatever you want, create a signal, make the monitoring system send an email, a message to the WhatsApp. Every time, this bit here is 1. Every time the machine starts a tool change cycle, send a message to my WhatsApp or to my email or to my text my phone. You can, the sky is really the limit regarding what you can do when an event happens on the machine. Okay, so now let me move to the MDC, which is the monitoring portion of this. I want you to understand that monitoring is something that, I want you to understand the basic principles here. So let me show you what this looks like. So if I log into the monitoring system and I want to see the event logs, if I have 30 machines, 100 machines, what's going on in real time is that all of them are sending messages to the monitoring system. So the monitoring system is just like a parser. It interprets messages. And where do you define messages? Let's say I have a message that doesn't exist. Like we were talking here about monitoring M6. So I could go here and say, I could create a message saying, message is M06 in motion. And I could add another message and say M06 not happening. Okay, so you create a message, and this message you can say this is an operator message he sends from the CNC control, or it's just a message that we get from the PLC, or it's an error message, whatever. So I'm gonna click apply. We go back to the DNC. Let's see if I open this, configure. And remember, I told you that I could monitor that flag, so I could go here and say for focus, look focus. I'm gonna, monitor that M06 variable. I'm gonna say M06 happening, and Boolean. I want 1 digit only, and I'm gonna put an address here. It was 0715 bit number 7, right? When it's equal to 1, I know that a tool change is happening on the machine. So what kind of message I want to send to the monitoring system? That if this condition is true, it's equal to 1, M06 is in motion. If it's not, if the bit is 0, it means the tool change cycle finished on the CNC. So to send a message that, M06 is not happening anymore. And now that I have these two conditions, I can make it, appear on live screens like this and show machine is changing, tool changes in cycle. I can put the text I want here because the first thing you need to do with DNC Max is to capture the event. Once you capture the event, once you know for a fact that this situation occurred on the machine, then it's really easy to, make whatever you want to appear on reports or TVs or live screens. So let me give you an idea of some applications here. So this is how, these guys implemented. I have an operator there that he was operating 2 machines side by side. So they wanted him to operate this from 1 single computer or 1 single tablet. He could create 2 tabs, 2 browsers on the computer. This is a PC with a touch screen. So he could tap, on the downtime reasons here, say, I'm in setup, I am in inspection, I have a tool breakage, or I need, CNC programmers to show up, I'm having a problem with the CNC. He can control, one or more than one machine, in the same terminal. So this is another example how they plug it, these devices next to the CNC, so the operator could simply, go there, tap the screen or see the status of his machine in real time. Okay. Coupled with the PDM product, we can also see, you see, a paperless environment. You can have, the monitoring system, the MES system, because we can convert that to a MES when we have the PDM, and then you can see documents, without printing anything. Any change made in SolidCAM, you output, you export a new to list, update the PDM. All clients in the shop floor, all computers in the shop floor now have access to the latest information without printing anything. Okay, another example here. This is a TV on the CNC programmer's office, so they could see, which machines they were responsible for, and if someone kind of, entered the downtime, I need a CNC programmer here, they could, do this and go there. So, hey, this program, I'm responsible for this process, and I need to go there to the machine to help them. And also, I want to show you a few videos here. So an example of not only having TVs in the shop, but also, no, sorry, in the office, but also in the shop. So the plant manager wanted to kind of, cause a good impression on visitors. So he built these stands, and put these large TVs because he wanted people in the cells to know and have like, some sort of accountability, like, hey, we're checking if your machine is running. We'll give you all the support you need, but I want you to know that the machine is being monitored, which is sometimes an issue. This is an example of, customers that have printer work orders with ERP systems. They can, use barcode scanners to scan a production order and enter that information into the system. You see, this is the production order number that he scanned, this one here. And you can see in real time that the live screens are updated. So you can see here that he's working on this order. From the live screens, in which order a given operator is working on. You see here the number. Okay. Another example here is operators, controlling the machine. So you can see, for example, part number, drawing revision, description of the operation, cycle time. You can see like remaining cycle time if that's what the customer wants. But in this case here, operator is going to enter a downtime reason, say, I need help from the CNC programmers. Someone needs to show up here at the machine because I'm having trouble. And why it did not change? Because the machine is in cycle. So if the machine is in cycle, we know that because we are reading from the PLC. So this is a way that, what I'm trying to say here is that operators cannot cheat the system and say, I'm having an event if in fact the machine is running. But if the machine is stopped, and we also know that electronically, then he needs to justify with a downtime reason. But he cannot enter a downtime reason if the machine is running as expected. Selection of operators. I think I showed here the work order. Yeah, it's the same thing. So let me go back. So everything that you are seeing here is an event. Okay, I can go here and I have this machine here, HMC 204. So how I would do this as an operator? Okay, I could go here and say, I don't know if you guys can see my phone. Okay, I'm going to show you that I can, control this from any device with a web browser. So MDC, I'm going to go here to an operator screen, HMC 204. And right now you can see here that the status is material, but I can click here on report downtime and say, I have a tooling issue now. Or I have report downtime again, I'm waiting on material again. Or I'm doing housekeeping. And I can even, So now let me show you how the PDM integrates with this. So I showed this to you, and we're going to create a new user here. Okay, I'm going to show you that we have a new operator. Right now I have Bob, and I'm going to create a new operator here called, Jason dot, Smith, uh, Jason Smith, and Jason is part of the operators group. So now if I go to my monitoring system, I can do this also from my phone, but I can go here, operator screens, and I want to control or operate this machine, and I want to change the operator. So now I have Jason Smith. So you see how the PDM starts to interface, and if I go here and show the real-time screens again, now I have Jason, not Bob. And I can have a production order as well. So monitoring is really a lot. I want you guys to see that we have the ability to generate reports, Excel tables. There are multiple possibilities for the system. I can see these are my machines, the time, the part numbers I run, the minimum cycle time, the maximum cycle time. So these reports, they are extremely configurable. You can go here, select a report, and say, I want to see cycles, and this is everything I can choose, like variables from the system, timeline, the machines, name of operators, programs that they run, work orders. You can put all this information. What I'm trying to say here, guys, is that this is not a technology where we put the customer on a leash. Okay, we are not uh, tying them to us in the sense that they need to buy reports from us. We can sell all these as services. You want a new report? You don't know how to build? We can build that as a service. Okay, we can customize the software any way the customer wants, and we can charge for that. But we can also train them, and they have autonomy to build reports. It's not like, hey, you have to pay me every time you want a new report because you don't have the ability to create reports yourself. So this is something that I want to show you. For example, reporting is really extensive. We could spend, a day talking about it. So instead of doing this, I'm going to show this on the Simco website. I want you to see uh, very briefly the capabilities we have for reports, the type of reports we can build. You can configure this. You can even export this to Excel if the company already has like templates, formats that they want to keep using. We can send that. Uh, what else we can do? We can do this as well. If the customer says, I'm not happy with the current, reports, I want more advanced things, we can have solutions like Grafana, which is like an alternative to Power BI, open source, very powerful. You can, configure reports having very advanced capabilities, timelines, everything. Simple can do this as well. But if you want something even more powerful, you can build with Grafana. Or you can also go here and say, well, I want to have Power BI. You can also do that. You can have the NC-based client, like I said yesterday. Let me see, Jason.Smith. Let's see what Jason can see. Yeah, all the programs. So we can run this, guys, on a cell phone or in the CNC machine. Okay, nobody needs to install anything. It's same functionality we have, in the in the desktop client. Okay, so just to finish here, I want you guys to have an idea how easy it is, for example, to put a new button here with a downtime reason. Okay, so what I'm trying to say is that we don't need, and this is also a selling point, we do not need the customer or our team to have any programming skills, HTML, C++, nothing. Okay, if you want to, just change the layout of a dashboard or a screen, it's as simple as this. So I'm gonna go here and say downtime reasons. These are my buttons there, and I'm going to add a new button, and I'm gonna say, forklift. I'm waiting for the forklift. So better than that, I'm gonna copy one that already exists, so I can make it right in the first shot. So let's say this one's gonna be forklift. I want the color of the button to be this or a custom color if you want. And when, this is very important, when that forklift uh, button is pressed, what message I want to send to the MDC system. And I'm going to say, hey, M06 in motion, for example, the message I just created. So everything to the monitoring system is a message. So I click on apply, and now we can go back here, and where is my forklift button? In the top of the screen. I could move it. I could say, hey, I don't want you there. I want you here. Okay. And then forklift is here. You say, hey, everything is in English, but your interface in the software is in Portuguese. For you guys working with customers with large plants or that want to have, let's say the CEO or the guys from corporate in the United States wants to monitor the status of the plant in Thailand or in Malaysia. Okay, so you can build the interface in Malay, but you can also build the interface in English. There's a translation functionality here on the software, so you can go here and say translations. Uh, these buttons or these commands in the interface, this is their translation, and for English, this is the translation. So now the CEO in the US can go here and say, I want to see everything in the UI in US English, but the guys that are running this solution at the plant, they can change to Malay or Portuguese, and the whole interface is translated, so they can nobody needs to have multiple copies of the same configuration just because they are monitoring different plants in different locations. You could have everything, one single configuration with different translations. Okay, so monitoring, really powerful. You collect the signals with the MDC Max, send this to the software. It's really big, so it's impossible on a webinar to show everything, but you can manage shifts of the company, messages, like I say, you can manage OEE. This is very important for many customers. If you want hardware outputs, you can drive a robot, you can start an event on a physical device that is part of your manufacturing work. So let's say you need, every time that the program, something happens in the program, you want the robot to do next to the machine to do something. You could send that hardware command to the robot from this. Can connect to ERP systems, database, financial systems, business systems with external I/O. So we can interface this with ERPs like SAP, Oracle, Microsoft CRM and all that, dashboards and all that. So really, really extensive. You can send notifications, like I said, even WhatsApp is supported now because you can have a web, notification. You can create really sophisticated things like let's see, HTTP, and this would be interface type HTTP, and if you have like the address of your a certain WhatsApp phone number, you could put it here, and that message goes to that number using HTTP. So very powerful. Okay. Uh, Let me see. So now I would like to show you the scheduler, okay, which is another product that solves many problems. I'm gonna do, a little configuration with you from the beginning so you guys can see how this works. It's very simple. Uh, Probably it also works in connection with the monitoring. So this is a scheduler that not only helps you to plan your work orders, but also exports this information or receives this information in real time to the monitoring, so if the spindle is running on that work order in real time. Okay, so let's just go ahead here. I'm going to create a new group and say SolidShop, Could be your just like horizontal milling cell. Could be something like that. And you're gonna say which machines you want to include on this cell. I want the horizontal machines. Okay. Uh, you need to set up your shifts. So I'm gonna say this shift from Monday to Friday works from it starts at 6 a.m. and ends at 22. It's active, and you also have another shift from 22 to 06 a.m. Same thing. So we have two shifts active. I'm going to apply this shift to all machines. I'm going to make a global change. It reads all machines you have on your DNC and on your PDM database as well. So I could have like administrators, they can do everything they want. And finally, I have this views where I want to create a custom view that says my name here is SolidCAM, and I want to have the machines with 108 pixels. When I open the software, I start with this, and I want to see everything here. Anything style, just a bigger icon here. So let's start with this. I'm going to close the application. Because I just configured it for the first time, we're going to restart the service. So the connection with the MDC and DNC Max is restarted to start monitoring that. Just start this. Now if you open the application again, and I can even have an option here to say, start this with the work orders, start planner after login, which is this, scheduler or planner. And I want to see a certain view here, horizontal milling cell. And I want to see, this filter here is the view that I integrate. So you see, I created like a view for these three machines. And here you can see the weeks I have ahead of me. You see, you're starting to see in real time the monitoring already, the colors that we have on the lights in the live screens. So there is a connection, okay? And let me show you now what it looks like to integrate this with your ERP system. I'm not going to create the orders manually here, but you can do really a lot of things. So I'm going to import this and say, I want to import XML files from my ERP systems like SAP, Oracle, whatever. So this is the directory where Oracle is going to export the files to me. I'm going to copy this path, put it here, okay? And now I have this little utility here that helps me to create, work orders for demonstrations. So I have XML generator. I'm going to start with this. I'm going to create like, 50 production order for us for these three machines. And I want to cover like a 60 days period for these demos. Okay. So generate. The second we do this, it's going to export XML files to this folder with sample data. Okay. This is normally exported by your ERP. So what the system is going to do is going to start to, capture these files and bring them to the database. I'm going to close this. View work orders. Just still importing them. Let me close this and open again. Because I just activate the import. Over here. Make sure that I did not leave anything behind. Server settings, import, active. That directory, I lost it. Simco 2024. So let me browse that. So Simco 2024, XML import, and okay. Scheduler, where are you? Yeah, files are not there anymore. The system, grabbed them. If we go here now, we have, work orders on the system, sample work orders. And I want you to see, for example, let's say that I need to see this view here. I want to see my horizontal milling cell. And I want to book these orders, okay? So this is, the ID. Let's say that I want the software to, schedule this product for me. So the first thing I have this option, schedule or not. And I have to select which ones I want, but I think there's an option here that allows me to select everything. Scheduling forward, auto, backward. Yeah. So you can search your orders, but in this case, I want the system to simulate for me like using backward scheduling. Like I have this delivery date, compute for me when I need to start to make this, to deliver on time. So the system is kind of saying, hey, these are your, scheduled times. But I can also go here, drag and drop, and say, I want to run this order here. View, work orders, and I can schedule that. So one of the things you can do with your orders, this is very important for you to understand. The order is one thing, right? When you expect to deliver, if the material is available or not, if it's started or not. But you also have the option to go here and say, I have operations inside this order. So let's say this is roofing, second two, side two, OP2. And I need to run this on this machine, and I want to manufacture like, let me see the size of this order is 242 parts. So same amount. It takes like, you can choose this 2 hours, and it take like, 2 hours, 02, 2 hours and 15 minutes to manufacture this part. Change over time, like the time you take, you need to change the parts. Setup time is 2 hours. And total machining time for this is 530 hours. And if this part needs to sit for a few hours before you can move it to the next machine or the next operation, I'm going to say it's going to be sitting on the floor for 4 hours before I can do this. And what happens is that I can say I also depend on this previous operation to be completed so I can start this operation. I can put the free description here, okay? And you also have events if you need resources and all that. So what happens here is that the system will schedule this job for us, and understanding the relationships and the dependencies between each operation. So let me move this to current day, today, and move this here. You can also schedule maintenance, okay? If you need to do maintenance on that given time. So let's see if we can schedule this and forward. And then I'm going to say, okay, and refresh. The software is a little bit stupid bored sometimes. Let's see if the orders were booked. No, they were not. It's probably because I just configured this. I have to replace my laptop yesterday, so I'm missing something. But let me show you what the scheduler looks like, okay? Scheduler. So I don't waste your time because we are on top of the hour here. So this is what it looks like. Okay, you basically plan your work orders. Then you see all your jobs, how they have, relationships between them. If you have external operations that, needs to be executed outside, like thermal treatment or coating or something, a capability you don't have in your shop, you can say this operation needs to be done externally. And then you can see all the orders booked with the machine and being monitored in real time. Just move this forward. Yeah, automatic scheduling in action. It looks at your slots in your weeks and say, I can, you know, yeah, fit an order here into this slot. Let me see if I can show you operations. Dependencies, so you can see how operations depend on each other. Like I need to finish this before I can do something. External operations, things that you cannot do at your shop. So I say this is external, is thermal treatment is going to stay for 1 day in an external vendor, so I can bring it back and resume manufacturing here. Yeah. Show you differences. What happens if you try to move an operation, simulate and say, hey, if you move this, you're going to push 3, 4, 10 operations ahead, or you're going to pull that. Maintenance scheduling, like I said. So the system knows how to work around your maintenance events and do not schedule things, when you're doing something. And finally, you have the monitoring solution working as a mini MES system. So you can go here, okay, and this is what I was trying to do, but the system let me down. So if I go here to the operator screen, let me just put this in English. If I go to the operator screen, MES, I can go here and say, I'm going to start, a work order, and I want you, yeah, I can do this because the software did not schedule the order, but what I can do here is, you know, operator screen, and start orders from here. So every time, for example, that the operator completes a part, my scheduler will say, hey, you need to finish 10 out of, 242 parts. So it starts to count that. You can electronically capture the signal of the ME30 on the machine. So every time ME30 occurs on the machine, you increment the counter on the scheduler and say, I completed another part. So you can remotely see everything that is happening, including the number of parts produced and everything. Okay, so uh, I had an issue here with my PC because yesterday I had to replace it. GoToMeeting was not working on my computer, and I probably left something behind here. But I wanted to show you, the general idea of SolidShop, monitoring, DNC, and the real-time, scheduler, which is connected to the monitoring software. You see these green lights here? It means I'm reading the status of the monitoring software, and I am updating the work orders accordingly. Okay, so I know we are on the top of the hour. I appreciate your patience. And like I said, send me messages if you have any doubts or if you want to see anything in detail. Next Tuesday, we're going to have the final webinar of the SolidShop series with, we're going to talk about licensing, pricing suggestions, and the business model, what we want to prepare you for, how to qualify your workforce, what you're going to get from us. We're going to try to cover a bit of everything and simulate some scenarios so you can see profit margins, cost for the end user costs. But we are on a very embryonic stage right now with SolidShop in terms of, the pricing and everything. So everything will be validated with our resellers and global sales managers for each territory. We have proposals right now. Next week we're going to present them, but at the end of the day, this is going to be, refined and to make sure that everybody's on board and understand the business plan and the margins and the benefits for the customer and also for us. Okay, so I see you next week then on Tuesday, and I hope that today you guys could have an idea of the technical capabilities of the SolidShop suite. Okay, thank you very much. Have a wonderful day, and again, appreciate your patience for staying until the end. Okay, thank you very much.